specific heat capacity. So the specific heat capacity is, first of all, we need to understand what is heat capacity. So heat capacity is nothing but the amount of heat energy required, the amount of heat energy required to increase 1 degree centigrade temperature. 1 degree centigrade temperature of the material is called heat capacity of that material. Heat capacity of that material. Now, the meaning of this is, suppose actually I have taken water. Now, I kept the water ball on the stove and then actually I tried putting heat. Then what happens is, if I take 1 liter of water, let us say, to raise the temperature from 30 degrees centigrade to 31 degrees centigrade, let us say, it took a time of, let us say, 5 minutes. So, to raise the temperature from 30 degrees centigrade to 31 degrees centigrade, and it took a time of 5 minutes. And then actually I have given a constant heat. Meaning, the amount of heat that was given to the water, it is absorbing and it is raising the temperature of the water from 30 degrees centigrade to 31 degrees centigrade. Now here actually, let us say the energy whatever I have given is of delta Q. Why we call this as delta Q is, so delta Q is always nothing but Q2 minus Q1. So difference of two values is always expressed as delta Q. So here actually the difference of the values is always expressed as delta. Now here actually Q2 minus Q1 is nothing but the change in the value of the energy there. So the change is actually from Q1 to Q2 actually changed. The amount of change is Q2 minus Q1. Now here if you notice, this is the amount of energy that was given to the water. So here actually, let us say this is the ball of water and then actually you are putting fire here. Now this is the fire actually we are putting at the bottom. Now the energy of the fire actually is given to this particular water. So obviously there is a reduction of this energy. Obviously actually this is the consumption of gas actually we can notice in our gas stove. And then actually the water temperature is getting raised. Hence actually it has got higher energy. So that energy is nothing but whatever is given here is taken by the water here. So this actually reduced energy is of Q2 minus Q1. The increased energy is again equal to the same energy Q2 minus Q1, but this is the increment of energy for this water and it is the decrement of gas in the stove, right? So the amount of energy that gas supplied is the reduction of the gas amount we can say, and the same amount of energy is given to the water here. And here actually we can notice that the same amount of energy is getting increased at this particular stage, and this value is of delta Q. And this delta Q is given and it raised a temperature of 1 degree centigrade. Let us say, suppose actually it is always not possible to raise only 1 degree centigrade and try to measure it. Let us say I know that how much of energy I have given to the stove and I know how much is the temperature actually it was raised. Let us say it raised from T1 temperature to T2, then the rise in temperature is going to be of T2 minus T1. So rise in temperature is of T2 minus T1 and the energy raise is going to be of Q2 minus Q1. Obviously, more the energy I give it, more the temperature is going to be raised. Now, more the energy and more the temperature, which means that actually these two are proportional to each other. Hence actually delta Q by delta T. So this is the change in energy by change in temperature. This will be the specific heat. So this is what we call as the heat capacity. Now here actually, if I give this value, suppose if I give this much of energy, this is the amount of the temperature raise. If I say that actually, in that actually there is some information that is missing out there. Now I am not saying that how much is the water actually I am putting in the stove, because I can keep 1 liter of water and I can give actually 10 joules of energy. Let us say it raised a temperature of 5 degrees centigrade. Now I kept 10 liters of water now, and the same 5 joules of energy only if I give it, will the temperature raise the same? Obviously it's not, because the amount of water I kept is more now. Now, meaning the amount of water is also playing the role in the heat capacity, how much it is getting absorbed there. So obviously you need to divide with the mass. So this is what delta Q by delta T. This is the change in energy by change in time, change in heat energy by change in temperature. This value is called as the heat capacity. And this heat capacity, if I divide with the mass of this, so delta Q by delta T, and this value is called as the specific heat. So usually this can even be represented as, so S is equal to 1 by M into dQ by dt. So this is also correct, because actually whenever we talk about the change, for very minor change, if you consider it, then actually we say that limit delta T tending to 0, then actually this will become the derivative which will give the accurate result. So the specific heat can even be defined as 1 by M dQ by dt. So this says that S is equal to 1 by M dQ by dt, and this value, the amount of heat energy required to raise the temperature of 1 kg of mass by 1 degree centigrade. One degree centigrade is called specific heat capacity. So the word specific is coming if you divide with the mass. Right? Obviously, the specific heat capacity, the units can be expressed as 1 by M into dQ by dt. Now here actually the units of dQ is nothing but the change in energy which is expressed in joules, and then divided by mass is expressed in kg, and temperature is expressed in Kelvin, kg Kelvin or kg degree centigrade, whatever it may be, right? So this is how actually are joules by kg degree centigrade. So this is how actually you will express the units of the specific heat capacity. Got it?